Hello, my name is Shintaro Momose, Principal Engineer of NEC Germany. Today, we are very glad to have the opportunity to introduce our vector supercomputer SX Aurora Tsubasa. Here, I'd like to show you the architecture of SX Aurora Tsubasa. This figure shows basic architecture of SX Aurora Tsubasa. Left side is controlling part and right side is processing part. The controlling part is very standard x86 server. x86 CPU, Linux OS, and the user can utilize library, tools, applications, etc. And right side, red part, is processing part. The big feature of this architecture is entire application is executed by this processing part. And this part has vector engine processor. Also, NEC provides vector compiler, vector engine libraries, vector engine tools. And in order to control this vector engine part, vector engine OS here can be installed onto x86 server part. This red part, vector engine part, is controlled by standard x86 Linux server. And this big feature of this processor is memory bandwidth, 1.5 terabyte per second per processor, with low power consumption, 200 watt. As you know, today's issue of HPC system is power consumption. The power consumption per system is getting higher and higher. In order to reduce or in order to maintain power consumption per system, lower power consumption per node or lower power consumption per processor is very much important, I think. Then the second page, processor characteristics, I'd like to show you here. Our processor provides high usability and high memory bandwidth per power consumption. The first figure shows the positioning of each processor. Y-axis shows specification, standard or high specification, and x-axis shows programming language, standard or something special. And x86, as you know, today's de facto standard, which can be utilized by very standard language. And as you know, GPGPU has very high specifications. However, in order to extract higher sustained performance from GPGPU, proprietary language must be used. Then our vector engine target is here. Very high specification can be used with standard language. This is very important point of our architecture. And high specification is memory bandwidth, 1.5 terabyte per second, which is provided by 6 HBM2 memory implementations. And memory bandwidth per power consumption. Compared to x86 GPGPU, our Aurora architecture provides highest memory bandwidth per power consumption, as this figure shows. Then, I'd like to show you the roadmap of our architecture. Now we are standing around here, V10E generation. And very soon, we are going to release VE20 generation. Each core has more than 300 gigaflops, and 10 cores are implemented into one processor, and memory bandwidth per processor is 1.5 terabyte per second, with approximately 200 watts per consumption. Then, near future, we are going to release VE30 generation with having more than 2 terabyte per second memory bandwidth. Moreover, we are going to release updated version of V30 as V40. 2 plus terabyte per second memory bandwidth will be implemented into this processor. And moreover, we are going to release here V50, which will have much more higher memory bandwidth and low power consumption. in order to accelerate memory bandwidth intensive applications. Okay, then let's move into the questions from ISC. The first question is, what is your company doing for its employees, the HPC community, and the world in the current pandemic situation? Because NEC is ICT company, we have had the remote work environment before COVID-19, fortunately. Although the COVID-19 is an unexpected situation for everyone, we can work for each home office with maintaining enough high working efficiency. For those colleagues who have to visit customers or have to come to the office because of some reason, we provide all protective equipment and guidelines to avoid the risk of COVID-19. Then, second question, how does your vector engine stacks up on memory bandwidth per watt versus ARM? Yes, with comparing an ARM processor for HPC, like Habium, the memory bandwidth per watt is same range as x86 processor from my view. Aura provides several times higher memory bandwidth per watt compared to today's x86 processors and ARM processor. And why Aurora provides high memory bandwidth with lower power consumption? Because we have vector architecture. 256 elements, 8 bytes each, can be handled by single instruction. Very simple hardware, longer lengths of vector lengths can provide high memory bandwidth with lower power consumption. And third question, can you explain how you see vector engine programming as standard, but GPU programming as proprietary? Okay, as for the Aurora programming, standard C, C++ Fortran language can be used. NEC's compiler provides automatic vectorization and parallelization functions. Moreover, the cache can be controlled by compiler, or user can optimize the cache usability to improve performance. The GPGPU coding has been improved from my view. However, to extract higher performance from GPGPU architecture, special coding and must understand hardware architecture is needed for users to extract higher sustainable. Then, final question, fourth question. Other than memory bandwidth, what other advantage do we get on the roll from B10 to B40 and B50? Okay, the most important point for NEC to develop our supercomputer is to provide high sustained performance, not impact performance. To accelerate memory bandwidth requiring applications is our role. A lot of applications require high memory bandwidth to be accelerated. To provide higher sustained performance, NEC will continuously provide architecture improvements. For example, at the B30 generation, cache architecture will be drastically enhanced in order to provide much higher sustained performance. Of course, we're going to provide higher flops per processor, but our main target to design our processor is to accelerate memory bandwidth requiring applications. Thank you very much for your kind attention.